Today we're going to be dealing with rational expressions as relates to complex fractions. Now, complex fractions are essentially fractions over fractions. And so I don't think we've dealt with that before. It seems really complex. It's not. But let's deal with this. It's not a rational expression, but if we deal with this, you'll see how we deal with rational expressions with complex fractions. Okay, the two fractions in the numerator have a denominator of 3 and 4. Okay, so we can't add or subtract fractions unless we have a common denominator. So the common denominator is 12. So let's change both of those fractions to a denominator with 12. So we have 8/12 minus 3/12. And I didn't go through that whole process of multiplying the numerator and denominator by 4 over 4 and multiplying the other numerator and denominator by, I think it was 3 over 3. That's something you should know by now. And if you're not real familiar with that, boy, you better go back to some earlier lessons, because I explained all this, and this isn't even algebra. It's not even really pre-algebra. You should know this already. But anyways, when we add or subtract fractions, we keep the denominator the same, and we only add or subtract the numerator. Again, I know I'm repeating myself. Anyways, 8 minus 3. Good. And now let's move to the denominator. And the denominator of the denominator does not have a common denominator. When I say denominator of the denominator, remember we're doing fractions over fractions. Okay, so to add these two fractions in the denominator, we need to have a common denominator. And so 6 and 2, the common denominator is going to be 6. So I need to change that 1 over 2. 2, 3 over 6, and now I can add them, and it's going to be 5 plus 3, and that is 8 over 6. And if that 8 looks a little funny, you probably saw that I turned that 5 into an 8 by just putting a cross through it. I can do stuff like that. I'm a little bit lazy, and rather than crossing out my 5 and then writing in an 8, just put a little cross through it. And so if you see me do that, don't think I'm weird. Well, I don't care. You can think I'm weird, but anyways, that's what I do. And it's 8 over 6, which can be reduced to 4 over 3. And now we still have a fraction over a fraction. Before we had like a couple of fractions over a couple of fractions, and we added them together to get just one fraction over one fraction. And believe it or not, this is real simple at this point, because that bar in the middle is a division bar. And so what do we do with division? We're going to flip the denominator and multiply. And now before we multiply, can we reduce these fractions any further? Let's see, we have a 5. No. I have a 3, and yes, 3 and 12 are both reducible by 3. Good, and that equals 5/16. And after all that incredible work, that's the answer. Now let's try this with a rational expression. And this is why I tried this with simple numbers first. Well, maybe not simple, but numbers first, so that when we get into variables, this doesn't look like just hieroglyphics or crazy writing. But anyways, we're going to do this the same way. Except in this problem, I have a 1 that is not a fraction. And I think we went over this before. As a matter of fact, I know we went over this before. If I'm going to add a number to a fraction, I have to turn the number into a fraction. So what's 1? That's right, it's going to be 1 over 1. Now, if I have to turn any whole number into a fraction, it's always going to be itself over 1. Now in this case it was 1 over 1. If that was a 4, I'd turn it into a 4 over 1. anything. Even if it was an x, I'd turn it into x over 1. But anyways, now that I have two fractions, I can add two fractions if I have a common denominator, which I don't. And so in the numerator here, our common denominator is going to be what? X squared. So to get a denominator here of x squared, I'm going to have to multiply that 1 times x squared. Whatever I do to the bottom, I have to do to the top. Why? Because x squared over x squared is 1. I've multiplied 1 times 1. I haven't changed a thing. It looks different, but it's not. So let's fix all that up so that it looks a little bit nicer and it's going to be easier to add. Okay, and before I move to the denominator, why don't I add this together? Now that I have a common denominator, I can add those or subtract it, whichever way you want to look at that. But I'm going to add x squared and -1, and it's going to look like this. That's right, at the risk of repeating myself, you add the numerator, but you do not add the denominator. The denominator stays the same. And so the denominator was x squared, and we're going to leave it that way. And now in the denominator, our common denominator is going to be what? X. Okay? So I'm going to multiply 1 times x. Yeah, 1 over 1 is going to be x over x. And now let's add those two fractions together. And that will be x minus 1 over x. And so that division bar in the middle tells us to take the denominator, that is the fraction in the denominator, and flip it. And let's run through it. Is there anything we can factor before we start cross-dividing? Well, look, we got the difference of squares. Did you miss that? Don't be missing that. Come on now. We have a square here. We have a square. Yes, 1 is a square. Don't tell me that. 1 is a square. It's the first square there is. Remember? 1, 4, 9, 16, on. Okay, so 1 is the first one. That's a real common one to miss. That's why I'm giving you the business. Okay? 1 is a square. X squared is a square. 1 is a square. And they're separated by a what? That's right, a negative sign. We have the difference of squares. And that's x minus 1 times x plus 1. Okay, now everything's factored out up here. So again, let's start way over here. X minus 1. Do we have an x minus 1 below? Oh, yes, we do. Okay, next, x plus 1. No, we don't have an x plus 1 down here. Next, x. Yeah, we have two x's down here. We have x times x. So, or you can subtract your exponents. That might be an easier way to do that, but x over x times x just leaves me with an x down here. Or if you want to subtract your exponents, it's going to be 2 minus 1. Okay? There you go, and that's our answer. And it's a little lopsided, but that's fine for homework. I don't want to see answers like that on the test. I want answers real crystal clear, like you're turning in a paper to your boss at work. If you write papers for your boss at work, make it look crisp and clean. And this isn't too bad, but I want it looking nicer than that. Do your homework.